Okay, so I am starting the recording and we will start at 3 o'clock. How many students are here so far? Okay, there are a few students. I want to ask, let me wait until 3 o'clock and then I will check. Then I will start. Okay, it's 3 o'clock already, so we can start now. So what were we doing last time? Anyone remember? We were doing the derivation of the relativistic momentum and the relativistic energy. And then we also talked about the relation between the energy and relativistic energy and momentum. Okay? We're talking about the relation between energy and momentum. So we got E squared is equals to mc square whole square plus b square c square. So this is our total energy, and we talked about relativistic energy and relativistic momentum. So are there any questions related to any of the topics we have done so far? And our first quiz is going to be on Monday. Okay? Our first quiz will be on Monday. So today, yes? जितना भी जो भी हमने क्लास में किया है वो कुछ भी आ सकता है, उसके अलावा भी प्रॉब्लम्स भी आ सकते हैं, कोई भी प्रॉब्लम्स हो, जिस तरह मैं आपसे कहूँ कि मोमेंटम फाइंड करें या कैलकुलेट करें या एनर्जी कैलकुलेट करें, कुछ भी आ सकता है।
मैम बुक में प्रॉब्लम्स हैं ना?
यस, तो उसमें से भी आ सकता है, कुछ भी आ सकता है, एनीथिंग कैन कम, इट्स ओपन एंडेड, ठीक है? लाइक एवरीथिंग वी हैव डन इन आवर क्लास, उसी से रिलेटेड प्रॉब्लम्स आ सकते हैं या डेरिवेशंस आ सकती हैं या इमेजिन सम सिचुएशन, सम सिनेरियो, एंड उससे रिलेटेड कोई भी कैलकुलेशंस आ सकती हैं जो रिलेटिविटी से रिलेटेड हैं, ठीक है? So what I was telling you last time is that if we have a coordinate system, we have two reference frames, ठीक है? This is our S frame and this is our S dash frame. So, oops, S dash frame. But basically, what I'm saying here is that if you have coordinates, if this reference frame S dash is moving in this direction with the velocity v towards the right, ठीक है, in the x dash direction. So if a point over here and a point over here, what will be the relation between the coordinates? Like if I have a point here, ठीक है, और x, y, इसकी coordinates क्या होंगे? x, y, z, and time as well. We also include the time coordinate. Why? Because maybe an event is happening, an event may not just we have the x, y, z, the position, but we also have the time as well. Right? We can also, something can vary with time as well. Okay? An event, like event can, like for example, if something is object is moving, फिर उसके time से भी relation होगा, ठीक है? So in this frame, what will be its coordinates? X dash, y dash, ठीक है? Z dash and T dash. Yes? So what do we want to do? What is the whole point of today's lecture? There's something known as Lorentz transformation, ठीक है? And first we will do Galilean transformation, and that is the basic simple situation. We will discuss that and then we will do the Lorentz transformation. So what I'm saying is that if this is a position x over here, ठीक है? और यहाँ पे this is x1 we have over here, and x dash, what will be x dash? If we have x1, which is the x coordinate in this frame, x dash क्या होगा? X dash, wait a minute, if I say that like if we have, for example, over here, this frame is moving with velocity v. So what will be the relation between x and x dash? basically this is moving towards the right with the velocity v. So it would have in a time t, if we have all these coordinates, so that means it's moving as well. So x dash is equals to x minus vt, because it has moved, this frame has moved, an object in this frame which is moving in this direction has moved an extra distance v times time, right? Does this make sense? Does this equation make sense to everyone? Why do we minus vt here?
मैम
Like, for example,
टी डैश नहीं होगा?
wait. No, not t dash, because it's the time as seen from this frame. We're talking about an observer in this frame. Like, okay, so let's see again. Let's go back to the situation. So x dash is as seen from this frame, as seen from this frame, as seen from s dash frame. This, an object over here, would move backwards, right? Because we know that this is s dash frame is the one that's moving towards the right. So if an observer is in s dash frame, observer, ठीक है, it's going to observe, if an observer is in this frame, same frame as s dash, where this frame is moving with velocity v. This is going to observe that s frame is moving backwards with velocity v, right? If we consider this to be the rest frame, this one to be the rest frame. Is that making sense? I mean,
Yes,
we
ma'am.
have two scenarios. One is the S frame. It's the, suppose we take this as a frame to be at rest and this one to be moving with velocity v in this direction. Now, if we are viewing from S dash frame, then if we were viewing from S dash frame, ठीक है, then this is analogous to this situation, ठीक है, we can go from here or here. So basically now this frame is moving, this frame will appear to move backwards relative to this frame with same velocity v. I hope this is making sense. Because we were viewing from S, so then this is moving forwards. So basically if we want to write x now in terms of velocity and time, what will that be? X dash plus v t dash, right? Can I write also a situation something like this, where यहाँ पे भी आएगा बाद में, here something like this, ठीक है, x dash plus vt dash. Is this making sense to everyone कि ऐसे क्यों हम ऐसे लिख रहे हैं कि इस फ्रेम, ये जो रेस्ट फ्रेम है, अगर हम उसको इस फ्रेम से बैठ के इस फ्रेम को देख रहे हैं एस डैश को, तो एस डैश is going to move forward towards the right with velocity v. And if we are viewing from this frame, if this is the rest frame, if we are viewing from this frame, then we are at rest with respect to the frame, this frame. So this frame will appear to move backwards with velocity v. Therefore, we write that the x coordinate of a position in this frame is equals to x, which is an object over here. This is its x coordinate, ठीक है, minus vt, meaning that this has moved backwards by a distance vt. Yeah, this distance by which it has moved backwards is vt. Therefore, we write that the x coordinate in the, as seen from this frame, will be x minus vt. Similarly, if we now, is this making sense? So now if I view from here, इस coordinate में अगर x है, तो what will that be equal to? That will be equal to x dash plus vt, right? Plus vt dash, right? Just इस frame में जितना time गुजरा है, उसको t dash, वो t dash है. So it will be plus vt dash क्योंकि it has moved towards the right or in the positive x direction with a velocity v, and in the time t dash, it would have covered a distance vt dash. So are these two equations making sense?
Yes, ma'am.
So we start with these two equations. So now This is now what I'm saying is that if this frame is moving towards only in the x direction, if the frame is moving in the x direction, then what will be the y coordinate? It will not change because there's no relative motion in the y direction, right? Both frames are not moving in the relative y directions, therefore y will be equal to y dash. Yes, and there's no relative in our. We're talking about this in this situation where it's moving towards the right with velocity v. We can also consider a different situation, but with moving where this frame is moving upwards with velocity towards in the z or y direction. But we're not doing that right now. We're deriving the simple situation, like the first situation we're deriving. So y is equals to y dash, and then z will also be equal to z dash. Because it's not, the frame is not moving in the z direction or in the y direction. So basically these two coordinates will remain the same, the y and the z will remain the same. Now what about the time coordinate? So like what we are saying right now, this is just something that we did not take into account time dilation or length contraction. ये basically हमने इसको सिंपल तरीके से लिखा है, ठीक है? हमने इसको सिंपल तरीके से लिखा है. This is not the Lorentz transformation. Lorentz transformation takes into account time dilation and length contraction, and that formula is going to be more complicated. This formula I'm writing over here, this is known as, these formulas are known as Galilean transformations. Why? Because we're simply subtracting or adding this time, this distance minus vt or plus vt dash. So we're just simply adding it. We're not taking into account the effects of time dilation or length contraction. Okay? So these are known as Galilean transformation. Why do we call them Galilean transformation? Because Galileo, at his time, Galileo, he did not talk about relativity. Okay? He did not mention anything about relativity, so we just call it Galilean transformation, where we basically just add or subtract the vt or vt dash, okay? To get the x dash, we will subtract minus vt. To get x, we will add plus vt dash. So that these four equations, basically 1, 2, 3, and 4, they constitute the Galilean transformation. So now what we want to do is we want to get the Lorentz transformation. This is not the same thing as Lorentz transformation. Why? Because Lorentz transformation will take into account will take into account time dilation and length contraction. So now what our goal is that we want to find Lorentz transformation, and let's see what to do now. How are we going to derive the Lorentz transformation? I will just show you, for example, what the form of the Lorentz transformation is. Where did it go? This is the Lorentz transformation, ठीक है? यहाँ पे it becomes basically the equation we had was x dash is equals to x minus vt, right? ये हमारे पास था. Basically now what's going to happen is that now this gamma factor will be there, and we're going to derive it as well. And t dash will be more complicated. It's not going to be simply gamma t. So we have to figure out what the Lorentz transformation is. And what do we mean by Lorentz transformation? It means the coordinates. The coordinates. So the coordinates at any, like, if you have two frames, then what if we have coordinates of an object in this frame, okay? What will be the coordinates? Its coordinates in this frame, if that frame is moving towards the right with velocity v. So I hope this is making sense. So now let's do some calculations, okay? So to convert velocity components measured in the S frame to their equivalents in the S dash frame, what do we want to do? Let's try taking derivative of x dash, y dash, and z dash, okay? So we're trying to derive the Lorentz transformation. So we will, because we're dealing with velocities as well, so we want to take the derivatives of the positions, because we know over here, let me erase this screen, it has become very messy. So we know that dx dt is the velocity. dx dt is the velocity, okay? So we want to see now, remember I told you before about Galilean addition of velocity. So I'm going to bring that again soon. But before that, let's start by taking the differentiation derivative of x dash, y dash, and z dash with respect to time. So let's see. If you take the derivative of this with respect to time, what will you get? dx dash by dt. We're taking this derivative with respect to t dash. Take the derivative of x dash with respect to t dt dash. Okay, let me write some things on the board. So if you have x dash is equals to x minus vt, okay? X minus vt. So now take the derivative of this equation, okay, with respect to dt dash. dt dash. What will you get? What will you get? You will get Vx minus V. Why is that? Wait a minute. X dash is this formula, okay? We're taking the derivative with respect to D. So what, wait, first one moment, one thing I want to tell you before we move forward. The Galilean transformation said that T dash is equals to time, right? Because we're not using relativity in the Galilean transformation. This Galilean transformation that I told you earlier, where if we have two frames and one is moving towards the right or left, one is moving towards the right, then we will observe this situation. And it's inverse, of course, which I wrote on the board before. Does that make sense? Those are called Galilean transformation. And in Galilean transformation, there is no time dilation because its Galilean transformation is the absence of relativity. Special relativity. So basically T dash will be equal to time. T
मैम
dash will be equal to T.
मैम इसमें गैलीलियन ट्रांसफॉर्मेशन में रिलेटिविटी
Yes.
होगी भी देना क्योंकि
Yes.
इसमें कोई चीज स्पीड ऑफ लाइट से तो मूव कर नहीं रही।
Yes, so yes, that's correct. स्पीड ऑफ लाइट के करीब कोई चीज मूव नहीं कर रही अभी के लिए हमारे जो अभी तक हमने कहा है। अब लॉरेंस ट्रांसफॉर्मेशन में जब करेंगे डेरिवेशन तो उसमें वेलोसिटी कैन बी क्लोज टू द स्पीड ऑफ लाइट, राइट? तो फिर उसमें फिर टाइम डायलेशन और लेंथ कंट्रैक्शन के इफेक्ट्स आएंगे तो टी डैश विल नॉट बी इक्वल टू टी इन द लॉरेंस ट्रांसफॉर्मेशन।
Yes, ma'am.
Yes? Okay, so now take the derivative. We were doing this. Take the derivative of this with respect to t dash. What will we get? We will get, this will be equal to v dash, vx dash, x for the x component, because this is the x velocity. This, right? This will be vx dash because it's tx dash, dx dash divided by dt dash, which according to this formula will give you the velocity in the x direction. So now that will be equal to, now take the derivative of this side with respect to dt dash. And because in the Galilean transformation we said that t dash is equal to t. So can I say over here that that will be equal to now dx dt minus v. I just took the derivative of this with respect to dt because t dash is equal to t. T dash is equal to t in the Galilean transformation. There's no time dilation in Galilean transformation. Therefore, I can say that Vx dash, this thing is equals to Vx dash because it's dx dash divided by dt dash. That will be equal to now Vx minus V. Now this is simple Galilean transformation. This makes sense, right? I mean, if you have two frames, ठीक है, and if there's an object here that's moving vx dash, यहाँ पे कोई object है, ठीक है, यहाँ भी कोई object है, and if this frame is moving with velocity v, as I mentioned in one of the earlier lectures, that if इसकी velocity अगर vx है, ठीक है, vx, and इसकी velocity अगर vx dash है, vx dash, so how you can relate the two velocities? No, wait. like अगर ये object है, ठीक है, यहाँ पे उसकी velocity basically यहाँ पे कोई object move कर रहा है, ठीक है, यहाँ पे कोई object move कर रहा है. So this is the rest frame, so we're observing from this frame. So we will observe it to be this Vx dash, which is the velocity in this frame, plus the frame velocity, right? So basically, if we're viewing it from this frame, we're sitting, observer is in this frame. Observer is in S frame, and there's an object that's moving with velocity Vx dash inside a frame S dash that itself is moving towards the right with velocity v. So according to Galilean transformation, it will simply be the addition of these two velocities, right? Which means that the velocity that an observer in this frame would observe is Vx, which is equals to Vx dash plus V. As I mentioned before, remember a spacecraft and passenger and Earth example that I told you once before? So if you rearrange this formula, you will get back the same thing, this equation. Vx minus V is equals to Vx dash. Okay? So I told you about an example before about a spacecraft, okay? If you have a spacecraft and there's a passenger on the spacecraft, okay, inside the spacecraft, and you have the Earth over here, okay? So this is the spacecraft is moving with velocity v. Consider that to be the frame, and the passenger is walking inside the spacecraft with velocity vx. You call it vx dash because it's as seen with respect to this frame. With respect to this frame. Is this making sense? It's seen with respect to this frame. So, as seen from the Earth, what will be the x-coordinate? The velocity. It will be v. It will be the summation of these two, right? Because that is just addition of two velocities. Because this has velocity with respect to the spacecraft, vx dash, and the spacecraft is moving with velocity v towards the right. So you will just summation these two, sum these two, and you will get vx as seen from the Earth. So this is Galilean transformation. It's simply the addition or subtraction. It depends on which frame you're seeing from. So that was that, and now we are taking derivatives. So we simply differentiate, so we get the same thing back. We get, now when we take the derivative, what are we getting? We are getting this equation, okay? Which makes sense to us because of this example that I told you, okay? So Vx will be Vx dash plus V. So if you rearrange this formula, you will get Vx dash is equal to Vx minus V. ये सबको समझ में आ रहा है? And because it was not moving in the y direction, y dash is equals to y. So we take the derivative of dy dash with respect to dt dash. That will give you dy by dt, which is the y velocity. ठीक है? And then you take the derivative of this with respect to dt dash. That will give you z dash divided by dt dash. So you get this thing, the velocity in the z direction. So this is the Galilean transformation and the Galilean addition of velocities. As seen from, if you're seeing from a different reference frame, ठीक है? If you're seeing from a different reference frame, another frame. So this is the Galilean addition of velocities, and later we will see that the Lorentz addition of velocities is very different. So, according to special relativity, Galilean transformation and corresponding velocity seems straightforward. Doesn't it seem very straightforward? This Galilean transformation is very simple, right? You're just simply adding that velocity or subtracting that velocity depending on which frame you're viewing it from. So Galilean transformation is very straightforward, but that violates special relativity. They violate the postulates of special relativity. And why do they do that? It's because if you have a system, ये सबको नजर आ रहा है PowerPoint? I mean, थोड़ा सा छोटा हो गया, लेकिन I want to put the whiteboard simultaneously here. I want to put them both here. ठीक है? So if I erase this now, and what I'm saying here is that why does Galilean transformation violate special relativity? Basically, if we measure the speed of light Speed of light can, the second postulate of one postulate of special relativity is that the speed of light c is not going to change with any reference frame, right? C will always remain the same. Light चली गई थी एक second के लिए. So speed of light will always remain the same for light. It will always remain this value, t, or approximately 3 into 10 raised to power 8 meters per second. Yes? But if we measure the speed of light, if you have two frames, okay, and this is moving forward in the direction v, then what will be, according to Galilean transformation, you're subtracting according to Galilean transformation, what was the velocity? What was the velocity? Vx dash is equals to v sub x minus v, right? Minus the frame velocity. So now if we are considering a light wave, see, for a light, we're considering light, okay? That's traveling in the x direction in the c system. Its velocity of the light in this frame is c. It should also be c in this frame, meaning that c dash should be equal to c. Do you understand what I'm saying here? But c dash should be equal to c. The speed of light will not change with relative to either of when we see from either of the reference frames. The speed of light is going to remain the same. But if I apply special relativity, if I use a Galilean transformation, I will get c is equals to c minus v. And this is not allowed, right? Because
Yes,
this
ma'am.
is not possible, because c dash should be equal to c. So basically, what we're saying here is that the Galilean transformation, it violates special relativity. So we cannot apply the Galilean transformation is a special case in the classical mechanics realm, but it does not apply for in the case of relativity where the speeds are close to the speed of light or equal to the speed of light. For example, we just saw a situation where we consider a light wave, ठीक है? So इस case में c dash is equal to c minus v, ये हम नहीं कर सकते. So we need to have a Lorentz. That's the motivation behind our derivation of the Lorentz transformation. We need to have a transformation that will give us. We need to have a transformation that will give us the same answer. That will give us c dash is equal to c. ठीक है? So now comes the next step, is that we want to derive this Lorentz transformation. And once we've derived Lorentz transformation, we will make sure that once we've derived Lorentz transformation, there's also something known as the inverse Lorentz transformation, वो भी करेंगे. और उसके अलावा फिर time dilation और length contraction को भी Lorentz transformation से ले सकते हैं. There are actually two methods of doing this, ठीक है? And let me explain this here. There are actually two ways of doing this. एक तो you have two reference frames, ठीक है? We have two reference frames. एक ये frame है और एक ये frame है, ठीक है? So this is S dash, this is S dash, moving towards the right, moving in the positive x direction with velocity v. And here we have S frame. So there are two things we can do. Lorentz transformation, let me call it LT. Lorentz transformation अलग से पहले derive करके situation से derive करके हम time dilation जिसको मैं अभी TD कह रही हूँ, time dilation, ठीक है, plus and length contraction, which I'm calling LC for now. You can, once you've derived the Lorentz transformation, we can easily get time dilation and length contraction we'll be able to prove that time dilation and length contraction is taking place from the Lorentz transformation. On the other hand, there's another method which we can do, is that time dilation or length contraction के principles से हम Lorentz transformation को derive कर सकते हैं. So there are two methods of doing this, ठीक है? But the one we'll be doing right now is this method, the first one.
मैम
ठीक है? Yeah?
मैम गैलीलियन और लोरेंट्ज ट्रांसफॉर्मेशन स्पेस टाइम ग्राफ से ना कर लें, वो ज़्यादा इजी है उस तरह.
Space-time graphs.
कि आप x एक्सिस और टाइम को y एक्सिस और Distance
No,
को
no, no.
access.
Time is not the y-axis. Time is not the y-axis. Let me just check. Time is different, ना?
मैम वो कह रहा है कि मतलब स्पेस और टाइम को दो कोऑर्डिनेट्स लेके इस तरह से सॉल्व कर लें, यानी कि एक एक्सिस पे स्पेस हो, एक एक्सिस पे टाइम हो, तो
मैम
इस तरह से हम
उस तरह काफी ज्यादा इजी हो जाता है लॉरेंस और गैलीलियन को समझना।
यस मैम, अगर 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 एक
Yeah,
चीज़
like,
अगर एक चीज़ बहुत ज़्यादा स्पीड से चल रही है तो वो सिर्फ टाइम में मूव करेगी, मतलब स्पेस में मूव नहीं करेगी। So,
okay, maybe you should do that as an assignment then, because I've prepared a different derivation. There are lots of different ways of deriving Lorentz transformation, actually. You can do it by this method as well, time dilation and length contraction ko leke, aap Lorentz transformation ko derive kar sakte hain. Lekin the method that I'm doing right now is this one. There are other methods you can use many methods. I mean, there are other methods of solving the same thing, right? So, I mean, if you want, you can do that as a homework. I don't mind. But I'll be doing it in one particular way, and then maybe in the next lecture I can teach you this method as well. ठीक है?
ओके मैम, थैंक यू।
Okay. So what I'm saying here now is that now we want to derive the Lorentz transformation, and from the Lorentz transformation we will make sure that time dilation and length contraction are obeying the Lorentz transformation. They are like being fulfilled. The postulates जो कि हमने पहले कहा था, time dilation and length contraction, they are going to be obeyed, ठीक है? Like I'm going to show you here, it says, the example says derive the relativistic length contraction using the Lorentz transformation. हम दो तरीके से इसको solve कर सकते हैं, ठीक है? Time dilation and length contraction, you can get it from the Lorentz transformation. You can do the reverse as well. Time dilation, length contraction को use करके, length contraction को use करके Lorentz transformation derive करेंगे. लेकिन I'm going to start with this one now. Okay, so now where are we? Yeah, we are here. So now we're saying we have the Galilean transformation, ठीक है? उसके साथ उसको हम लेके क्या कर सकते हैं आप? So we have to start with a guess situation first, a guess formula, और उसको हम manipulate करके फिर हम actual correct relation determine कर लेंगे by means of certain conditions. So we will see now. So basically what we're saying is that a reasonable guess is that if there's a minus sign here, well, actually, वो आया नहीं था, वो पता नहीं कहाँ से गायब हो गया है minus sign, but there's a minus sign between these two terms here. So x dash is a reasonable guess if we're saying that Galilean transformation goes by x minus vt, then we can simply say that we can guess that x dash should be some factor x. Wait a minute, where's that formula here? Yeah, so it would be k times x minus vt, where k is some factor we want to determine. So what we're saying here is that if we have x dash, let me just do this so that we can see this as well together. So x dash is equal to v x minus v time, ठीक है? So now this is a Galilean transformation. So we will guess a solution for the Lorentz transformation that x dash can be some factor which takes into account time dilation and length contraction as well. K factor, we call that the K factor, is equals to K times x minus vt. ये कह सकते हैं guess कर रहे हैं अभी, फिर हम find करेंगे what it actually is. So for now, we start off with a guess factor. Here, k is a factor that does not depend on either x or t, but it can be a function of the velocity. So k does not depend on the x, it does not depend on the time, but it can depend on the velocity. Why are we doing like that? Because we have two reference frames. We have two reference frames, right? We have two reference frames, and this frame, k takes into account the k is a factor that varies with, like, that takes into account the velocity of the reference of the frame that's moving with respect to another frame. So, but x and t are coordinates that depend on the frame that are for a particular frame. right? Like if I have s dash here, then x dash is a coordinate in this frame, and x and time here are coordinates in this frame. But we want a relativistic, some factor k, which takes into account this velocity is independent of the coordinates of the position, or it's independent of the coordinates of the object. Whether it's x, y, z coordinate or time coordinate, it's independent. This factor k is independent of the coordinates, but only depends on this velocity where one frame is moving with respect to another frame. So that is our guess situation. And then we will talk about several considerations as well. This case should be linear. Several considerations. The choice of this equation is going to follow from several considerations. Okay? So that it's linear in x and x dash. What do you mean when we're saying that it's linear in x and x dash? So that a single event in frame S corresponds to a single frame in frame S dash. What do you mean by this equation? It's linear in x and x dash, so that, I mean, if you have y is equals to mx plus c, that this is a graph of a straight line. So basically this m over here is independent of x. Yes? So it's just the slope of the graph. So what we're saying here is that this equation here is linear in x and x dash, meaning they are changing by a linear factor. What do you mean by that? Any idea? And it's also simple, and we're saying that this equation is simple. It has a simple solution. Okay? It's not, we are going to start off with a simple guess. Like over here, we're saying that this is a very simple situation, like a guess. And we're going to start off with a simple thing because whenever we try to solve a problem, we want to start off with the simplest possible solution to the problem. If that does not fit, then we will go on to more complicated solutions. But we will start off with the simplest possible guess. So we have a situation like this, okay? And then it has the possibility of reducing to 1.26, which we know to be correct in ordinary mechanics. 1.26 was this equation. Let me just go back there. It reduces to the Galilean transformation in the case of ordinary classical mechanics, yeah? So it has to follow these three conditions. Our guess that we made over here has to obey these rules, okay? Some considerations, these are three considerations that we're taking when we're making a guess like this. So one of them is that it's simple, so we're going to start off with a simple guess because that will be the most straightforward way to approach this problem, and then it will reduce to this equation has to reduce to Galilean transformation in the simple case that we are not considering special relativity in ordinary classical mechanics. So now we go to the Lorentz transformation. Now I want to tell you a little bit about inverse transformation as well. Inverse transformation, what's going to be, like if I have a formula for x, if I have a formula for this formula over here says that x is in terms of what? X dash is in terms of x and time, okay? So how can I write a formula for x in terms of k? Well, k will still be a factor here, but when I want to inverse the situation, I will write it in terms of x dash plus vt dash. And why am I doing that? Because the only thing that's changing is that these coordinates, so basically what we're doing is that we're not we're not rearranging this equation to make x the subject of the equation. In that case, k would be in the denominator, right? But we're not doing that. Inverse Lorentz transformation basically just reverses the sign of v, and it switches x to x dash and t to t dash, and x dash here to x. And why are we doing that? Because if we are viewing from this frame, as I said before, this will be moving backwards with a velocity v. If I'm viewing from this frame, then an object in this reference frame will be appearing to move backwards with a velocity of v. So if I have coordinates of an object over here, let's go, for example, x dash t dash कहेंगे for now. X dash and t dash. we're neglecting we're not talking about the y dash. Y dash and z dash will be equal to, y dash will be equal to y and z dash will be equal to z because there's no relative motion in either the y or the z direction. Make sense? So the only difference between, what is the difference between this equation and this equation? I mean, इन दोनों का फर्क क्या है? हम क्यों ऐसे लिख रहे हैं? हम इसको like x की equation को लेके इस x को हम subject नहीं बना रहे इस equation से, because then if we do that we would get something like x is equals to x dash divided by k, right, plus bt. Yeah, we're not doing that here. We're not doing that because inverse Lorentz transformation is not defined like that. Inverse Lorentz transformation is defined basically जो v का जो sign है यहाँ पे उसको change कर लेते हैं, plus कर लेते हैं और इसको we replace this with x dash, this with t dash and this with x dash. And why are we doing that? Is because if we are now observing, let me make the whiteboard bigger. If we are now observing from this frame, basically no, इस frame से observe करेंगे तो coordinate x dash होगा ना, x dash will be the coordinate, and this is our factor times the Galilean transformation that we had. This equation makes sense. Why? Because the Galilean transformation said that अगर यहाँ पे उसका coordinate x है, then it's going to appear उसका, if the frame is moving backwards with velocity v, then it will be, the distance will be x minus vt because it's moving backwards with velocity v times some factor which we are going to derive. ठीक है, ये derive करना है हमें. So now what is the basis for this inverse Lorentz transformation for the x only? So अगर now if we're viewing from this frame, यहाँ पे x है, ठीक है, उसकी position x है, and the Galilean transformation will say that if this is x dash plus vt, right? Because it's moving forwards with the velocity of v, plus vt dash is moving forwards with the velocity of v, and the time in that frame was t dash. Is this making sense to everyone? You समझ में आ रहा है? And then we will apply the same k factor. Whether we are viewing from this frame or this frame, it's not going to become 1 over k. It will remain k because it's just orientation. It's just viewing from a different frame. You समझ में आ रहा है सबको? As seen from this frame, an object here, if it had an initial coordinate x dash, its coordinate will be x dash plus v t dash because it has moved forward by a distance vt dash. So it's just similar to this one, but it's this is one of them is called the inverse Lorentz transformation. Yeah, this is the inverse Lorentz transformation where we just have this term. We add plus v here and we put it x dash and t dash, and this will be x. Is this clear to everyone? Yes or no? No? ये इनवर्स लॉरेंस ट्रांसफॉर्मेशन की बात नहीं समझ में आई किसी को? आपको दो आ रही है? ओके ठीक है. Okay, I hope सबको आ रही है, ठीक है. So y and y dash, z and z dash are still related by the same formulas. Why? Because we said that there's no relative motion in the y or the z directions, ठीक है. So basically these will remain the same. So now we will do some algebra, ठीक है. हम थोड़ा सा algebraic calculations manipulation करेंगे, ठीक है. So the time coordinates t and t dash are not equal for Lorentz transformation because we know that time dilation takes place, ठीक है. So they're not equal and we want to find a relation for them. We want to find out what is t and what is t dash. So let's see. So now ये हमारे पास जो x, ये जो हमारे पास x का formula आ रहा है, इसको आप 1.33 is 1.33 is this formula. Put x dash का formula. This is a minus sign between x and bt. ये नजर नहीं आ रहा इसमें. but there's an x, this is k, x dash k into x minus vt. इस फॉर्मूला को लेके आप इस फॉर्मूला में x dash की जगह डाल दें तो क्या हो जाएगा, थोड़ा सा algebra हो जाएगा, ठीक है, हमारे पास ये इक्वेशन आ जाएगी. And if we replace the formula for x dash, which is in terms of x and v and time and k, ये formula जो है, we'll get rid of x dash, and now that will be in terms of x, v and t dash as well, and k. ये समझ में आ रहा है किस तरह ये equation आई है? I mean, if you all were here in IST, I would have done all the algebra and on the board, but because this board takes so much time and the algebra is going to take a lot of time to write all the equations, so I know that you can do this on your own, right? So basically, as a homework for your own understanding, you should try to do all these derivations, okay? Do these steps, but I'm not going to ask you to submit it because it's too simple. So you put our value of x dash into this equation for x, and now you will get this formula, okay? From which we find if you make t the subject, t dash the subject of the formula here. ये हमारे पास t dash है, इसको subject करें, rearrange करें इस formula को, we will get in terms of t, हमारे पास t का coefficient क्या हो जाएगा यहाँ पे? We have k square minus b k square. इसको बस rearrange करके t dash का subject of the formula बना दें, so we will get this equation, ठीक है? Now, we have, what do we have so far? We have 1.33, this coordinate for x dash. We know that y dash will be equal to y, z dash will be equal to z, x dash is equal to this, and we know that t dash is equal to this. So we have some coordinate transformation a little bit. These coordinate transformations satisfy the postulate of special relativity. And what we want to do now is that the second postulate, we want to use that, which says that, what will the second postulate say? The second postulate says that the speed of light is c, right? So we want to use that second postulate of relativity. We wanted to evaluate our value for k. ठीक है? So we have, so far the Lorentz transformation we have is these two equations, this equation and this equation, because it defines our x dash, y dash, z dash, and our t dash. So now what we want to do is we want to find k. We don't have k yet. So what are we going to do to find k? We have to consider situations. Again, another situation, okay? At instance t is equals to 0, what happens if at the situation where t is equals to 0? If you have two frames, okay, t is equals to 0 and t is equals to time is 0. Like time has not started, so the event time is 0 in this frame means that time is also 0 in the other frame. Can I say this? Because the event has not started, right? So how there can be any time dilation or any effect? Time is just 0, like the event is not started. If an event, अगर कोई event है, like a movement, a motion in this direction or something, time has not started, the time dilation हो ही नहीं सकती. So basically t will be equal to t0 is equals to 0. I mean, is equal to t dash is equal to 0 in the beginning. Is this making sense? So pair both observers must find the same speed c. Figure 1.23, where's figure 1.23? I don't think I put it here, but anyway, which means that in the S frame, did I put it here? No, I did not. So anyway, in the S frame, x is equals to ct, x is equals to c times t. At any point, if we're talking about light, it will obey this principle, right? If light is moving, light moves with a velocity of c, and if we're talking about a light pulse, for example, that's moving in any direction, in all directions, it will have the same velocity c, but we're talking about the x direction right now, so light is moving with the velocity with the speed c. So we have x is equals to ct at any particular point in time. Yes? And then in this frame, it has to obey the second postulate of relativity, so it will be Ct dash. Yes, if T dash is the time that has elapsed in this frame as dash frame, then X dash will be equal to Ct dash, because it's also we're talking about light that's moving with speed c. Make sense? यहाँ तक सबको समझ में आ गया? Okay, so now substituting for x dash and t dash in equation 1.39, इस equation में आप x dash का जो हमारे पास Lorentz transformation आया था, ये जो हमारे पास x dash Lorentz transformation and ये equation t dash का है, इन दोनों को आप इस equation में डाल दें. You will get something, you will get the x dash on the left hand side of the equation. Who's saying something in the chat? आप प्लीज जो चैट में बोल रहे होते हैं ना, लिख रहे होते हैं, आप प्लीज वर्बली बोल लें ताकि मुझे चेक ना करना पड़े.
मैम वो बताना था कि टाइम हो गया.
अच्छा, बस 5 मिनट और दे दें, ठीक है? मुझे 5 मिनट दे सकते हैं मुझे और?
क्लास से पूछो.
You have another class at 4?
नो मैम.
तो फिर x is equals to ct and x dash is equals to ct dash. So basically, I will just quickly wrap up. But if you put the equation for x dash in here and the equation for t dash in here, what will you get? You will get kx minus bt, which was the equation for x dash. And then you put the equation for t dash in this equation. You will get something that looks like this. C into kt plus this factor, okay? And now you solve for x, make x the subject of this equation. You have one x over here, there's no x in this term, there's one x over here. Make x the sub, rearrange this equation to make x the subject of the equation. And I expect that you will all do this algebra on your own as well to get to verify these equations. So x is equals to this thing. So now just take c and t common. You can see that there's a ct here, there's a t here. So take ct common, इसको ये जो यहाँ पे v k t है, ये divide by c हो जाएगा because we took ct common, और ये हमने ले लिया, तो फिर we get with this formula. So now we knew that x is equals to ct. ये हमने कहा था x is equals to ct, which means that what should the term in square brackets, what should it be equal to? If we know that x is equal to ct, तो फिर ये जो term है square brackets में, इसको क्या value होनी चाहिए? इसकी value 1 होगी ना? ये 1 होगा तो फिर x is equal to ct बनेगा, अगर ये सारा सब कुछ 1 होगा, equal to 1. So we set this equation equal to 1, इसको rearrange किया, हमारे पास k आ गया, which is the gamma factor. Easy, simple. So I won't go to this example right now, but before I finish, I will say now that we have got the equation for k, which is the gamma factor, we will put it back into our equation for x dash and t dash. So our equation for x dash was here. Isko gamma factor dal diya, so we will get x minus vt dash. Sorry, we will get x minus vt divided by this factor, and this tells you about time dilation, doesn't it? Sort of obey time dilation. हम वो भी देखेंगे. It looks as if it does because this is a distance and this is a distance as well. They're separated by a factor of, this is the proper time, right? This is one of these two. They're related by the gamma factor, and we've studied that before in length contraction. Sorry, not time dilation. This obeys this. We will prove that this obeys the length contraction. But as you can see from here, because this is a distance and this is a distance, they're related by the gamma factor, which is 1 over this thing, okay? So this basically it shows that length contraction is being obeyed. And then we have y dash is y same because there's no relative motion in the y dash or z dash direction or the y or z direction. And then if we put the value of k back into the formula for time, t dash, k ko यहाँ डाल दिया और यहाँ डाल दिया और यहाँ डाल दिया. What will we get now? We will get an equation that looks like this. So these 4 equations constitute our Lorentz transformation. And this is t minus vx over c squared divided times the gamma factor, which is 1 over this factor, this number, the square root. 1 minus v square over c square. सबको समझ में आ रहा है?
Yes, ma'am.
Okay. So ask any questions, please. Anyone has any questions? We will do up till here जहाँ हमने किया है ये quiz में आएगा because ठीक है up till the derivation of the Lorentz transformation from here, and then next class we will do the rest of the slides, which are some examples: inverse Lorentz transformation, example 1.10, and we will do velocity addition, ठीक है, example invariance और ये बाकी pair. We might also do the derivation, we might also do the derivation of कहाँ पे हम रुके हैं यहाँ पे रुके. We might also do, like as I said before, that there are two ways by which you can obtain the Lorentz transformation. One is the forward way, one is the backward way, and one way is by starting with the time dilation and length contraction, then getting Lorentz transformation. The other is that you have the Lorentz transformation, then you derive from there, you get the relativistic length contraction and the time dilation from the Lorentz transformation. So we'll finish this on Tuesday, because on Monday we will have a quiz, or Monday if the quiz is short and we finish and all of you finish on time, then we will continue this on Monday. Any questions now?
मैम क्विज में ये आएगा, ये वाली डेरिवेशंस आएंगी अभी कंप्लीट नहीं हुई
कुछ
हैं
भी
अभी.
आ सकता है, anything we've done. I mean यहाँ तक तो हमने derive कर लिया ना, Lorentz transformation तो derive कर लिया है. I mean if I ask you to derive Lorentz transformation, then I would say that you have to start from the guess equation, right? And then find k using the same method. But I mean, I might give you problems or something else that can like utilize these derivations. I won't necessarily ask you to derive like anything, but I mean, I can ask you to derive, I can ask you to do problems, anything can come. Okay?
मैम
Up till from here we have done so far. Yes?
इट विल बी डिस्क्रिप्टिव मैम, क्वेश्चन पेपर देंगे और हम उसको सॉल्व करके वही स्क्रीन
MS
शॉट्स
Team
निकाल
पे
के.
MS Team पे मैं जिस तरह हमने फाइनल एग्जाम लिए थे ना,
या
वही
मैम
या
MS
अटेंडेंस होगी.
अटेंडेंस तो होगी ना ऑब्वियसली. क्विज में अगर आप एब्सेंट हुए तो फिर क्या होगा? एब्सेंट ना होना, everyone knows that we have quiz on Monday, ठीक है? So if everyone knows we have quiz on Monday, if anyone has a valid reason to be absent, like a medical certificate or something, then I can retake their quiz. But otherwise, or internet connection का मसला, I don't know about internet connection. इंटरनेट कनेक्शन अगर किसी के पास सीरियस इशू है कि वो लाइट चली गई हैं या कुछ, फिर मैं उनका क्विज रीटेक कर लूँगी, ठीक है? लेकिन you can't just, I expect none of you to like just say that just to avoid taking the quiz, because then मुझे एक और quiz बनाना होगा, or likely if I make another quiz for those who have medical reason or lights off reason, I will make that more difficult, the second one. So this is motivation for all of you to be present in the first quiz. So the second quiz, if there is a makeup quiz, that will be harder than the first one. I'm just telling you, right now, because I don't want you all to like just make lame excuses, ठीक है? Because I mean, the makeup quiz will only be in certain situations as well, and in that case, like the makeup के लिए ज़्यादा time भी मिलता है तैयारी के लिए, तो उस case में makeup should be harder technically speaking as well. So are there any questions? I hope that you're all revising all this material on your own when you go home, ठीक है? I mean, you're already at home, but I hope that you're all revising all these topics, everything we've covered so far, ठीक है? And today is 24th, the quiz will be on the 28th. Yes? ठीक है?
मैम
And
सरप्राइज
so
क्विज है ना?
नहीं, सरप्राइज तो नहीं है.
नहीं
मैंने
मैं वैसे पूछ रहा हूँ आगे.
हो सकता है, लेकिन I would generally say that surprise quizzes अच्छा. What is this? Kindly keep these comments. Okay, sorry. I was just reading the comments in the chat. But anyway, what I was saying is that surprise quizzes, I try not to take them because I understand that anytime someone might not have preparation or
मैम
that internet का issue हो सकता है, yeah?
यस
But
मैम,
हो सकता है
जब तक ये
कभी,
ऑनलाइन
yeah,
प्लेटफॉर्म
जब
चल
तक
रहा है ना तो
online
ये
surprise
सरप्राइज क्विज नहीं होना चाहिए मैम.
नहीं होना चाहिए. I agree. So अभी I'm announcing this quiz ना, Monday का जो quiz है वो announced है. तो मैंने
Yes.
लास्ट लेक्चर में बता दिया था, तो मंडे को
Yes.
ये क्विज हो, ठीक है? So any other questions, और ये क्या कमेंट्स आ रही हैं
मैम
चैट में? यस
मैम डोंट रीड
मैम
देम।
मैम जिस तरह आप
क्या?
क्विज ले रही हैं ना, इस तरह वैसे बाकी टीचर्स ओएचटी लेते हैं, यानी डेरिवेशंस और ये प्रॉब्लम्स और इस तरह की चीजें
आई
ना।
नो,
क्विज
मेरे
क्विज
क्विज
तो
थोड़े से
बहुत
लंबे होते हैं।
कॉन्सेप्चुअल किस्म का होता है, वो एमसीक्यूज टाइप होता है, तो आप भी वैसे ही ले लें।
उनका कॉन्सेप्चुअल होता है, मेरे क्या होते हैं?
मैम हमारे में वो मैथ होती है और वो प्रॉब्लम्स वगैरह होती है ना, वैसे बात कर रहा हूँ। क्विज क्विज की जब हम बात कर रहे हैं तो वो बेशक आप एमसीक्यूज टाइप ले लिया करें, कॉन्सेप्चुअल
एमसीक्यूज
किस्म का।
एमसीक्यूज में कोई वो नेगेटिव मार्किंग अगर नहीं है तो कोई वो गेस वर्क से भी मार्क्स ले सकता है ना, तो उसमें फिर अच्छा नहीं
मुताहिर
होता। एमसीक्यूज
तो हम
अच्छे नहीं
नेगेटिव
रहते हैं
मार्किंग ऐड करते हैं।
उसमें, नेगेटिव मार्किंग ऐड करते हैं तो फिर we will see, okay, I will see, but I prefer problems because calculations बहुत important होते हैं, steps दिखाना, you have to show every step that you're doing, I mean the steps also in the calculation, so that I know that you're actually understanding. अगर MCQ हो, किसी ने guess करके कोई correct answer tick कर लिया, फिर उसके तो marks आ जाएंगे, लेकिन they wouldn't have understood it and I wouldn't have known, I won't know that they have understood.
Yes,
तो
ma'am,
नेगेटिव
वो
मार्किंग का देखेंगे, लेकिन I don't encourage MCQs. I encourage problems and written problems. ठीक है? So anyway, it's 4 o'clock now. I've taken a lot of your time, and let me download the attendance. I think did I download it already? Attendance की list download कर लूँ. फिर download attendance list. Okay, now we can end the meeting, and we're done for the week, right? Today is Thursday. Yeah.
मैम 16 से यूनिवर्सिटी खुलेगी
16 of what? October?
अक्टूबर।
I don't think so. अभी तक तो कोई हमें नहीं आया कोई भी कि यूनिवर्सिटी खुल रही है, and there are people are saying, the faculty and other people are saying that most likely the whole semester will be online. Most
Yes, ma'am.
likely.
मुझे भी एक प्रोफेसर ने
काफी
बताया था।
काफी जगहों से ये बात सुन रहे हैं कि whole semester will be online. So we have to stick with this. We have to stick
तो
with this.
जिन्होंने ऑफिस में बुलाया था।
जी जी हाँ मुताहिर।
Okay. Okay, anyway. Okay, so it's already 4:01 now, so I will just close this meeting now, and thank you everyone for listening, and I hope that you will all prepare for the quiz, and if you have questions, you can always ask me in the group, Modern Physics group, or you can ask me in the WhatsApp or email or anything, okay? Okay, so now I'm ending this meeting, okay? Yes?
Okay,
Okay.
ma'am.
Love Hafiz,
Okay.
everyone.
Love is.
Love Hafiz. Okay, who is sending me?